Hi, so this is another Talking Heads or visual podcast from the LUNZ Soil Topic Advisory Group, which I head up with Pete Smith here. And today we're going to be looking at the question of soil carbon sequestration. So we're all hungry for good news on carbon. And we hear that soil is obviously a massive opportunity in this space. However, sometimes non-experts like me are left confused because when I read some of the news in this space where companies or organizations are recording really big wins in soil carbon sequestration efforts, and then sometimes these are refuted or contested, or even worst case scenario, badged as greenwash, I'm left a little bit confused about where the science is. So we thought we would put the science to the test with two leading experts in this space, one of whom is my topic advisory group co-lead, Pete Smith here, and the other is Helaina Black from Agricarbon. So I'm just going to hand over to Helaina. Can you just say a couple of words about your background in this whole soil carbon game?
Uh, Thanks, Ellie. Hi, everybody. I'm Helaina Black. I'm Chief Scientist at Agricarbon, which is a little company based in Dundee that looks at direct measurement to support soil carbon projects. For those of you who don't know me, I've got a background in academic research, working in research institutes most of my career, and I'm still an Honorary Associate with the James Hutton Institute.
Brilliant. Thanks, Helena. And Pete, well, we know you well from this series, but you've done so much work in the soil carbon space. So maybe you could just give us a tiny bit of background on that.
Yeah, so I'm Pete Smith from the University of Aberdeen, and I've been working in soil carbon sequestration research for 30 years. And I've known Helena nearly as long as that. Doesn't that make you feel old? Makes me feel old.
Yes.
So looking forward to this discussion.
Brilliant. Let's jump straight in. And my first question is, so when you see a news study or an exciting claim featured in the press about successful soil carbon trial or study, what's your main sort of mental checklist? The things you want to know that would satisfy you that it's robust and really taking things forward.
Oh, well, I'll kick off here. I think I always say the devil's in the detail with these things. You always get media headlines, and it doesn't matter whether it's soil carbon or something else. You've always got to drill into the background of it. And I would always say, is there enough information provided either in the article or the supporting information associated with it that says I could repeat this, I could try and do it myself to see whether I could get the same results. That's the first thing. Does it tell you enough about the methods and how they've done it and how then they've analysed the data? Have they used mathematical models or used statistical techniques that you got confidence in? And I think absolutely critically, it's about what is the headline actually truly reflecting what the original authors have actually said? Because often there's a miscommunication between what people are actually saying something's achieved and what's then reported in the press. And it's a bit unfortunate often for those that are reporting things that maybe something is overblown or overstated that's not necessarily reflected in the paper. And then obviously as a scientist and an academic, you want to get into the information. There's enough information about the data that's actually presented to say, I've got confidence in the results. Who's producing it? Where have they done it? Has it been reproduced over a number of times, or is it a very short-term study and there's more work to be done? Because nothing's ever complete in any study that's reported. So it's often the acknowledgement of the weaknesses or the lack of information that needs to be followed up as much as making a statement about this is what it shows. I don't know, Pete, if you get anything else you want to
Yeah,
add to
that's a
that.
that's a great answer. Very objective. I also look at who did the work. So if it's a team that I know and I trust that have done good work, and I know they do good, robust work, they publish in the peer-reviewed literature, I tend to trust it more than if it's somebody I've never heard of working for a consultancy I've never heard of. And also, call me cynical, but I also look at who funded it, because there may be some vested interest. This is generally not in the paper, but sometimes in the communication of the paper, where the spin gets put on it. I'm looking to see who funded it, to see if there are any vested interests to show that soil carbon's going up, or that's going to offset nitrous oxide emissions or methane or something like that. Then I just look a little more critically at it. That's a bit cynical, but that's what I do.
Yeah, that's really helpful. Actually, that takes me on to my next question, which is, we hear a lot at the moment about projects that focus on building soil carbon in order to compensate for other things, for example, methane emissions. Obviously, that's usually in ruminant farming. So can you clarify how that compensation actually works scientifically?
Do you want me to have a go at that one first, Helaina?
I was going to suggest, yeah.
Yeah. Okay. So when soil carbon increases, that's locking up CO2 out of the atmosphere. So you've got like carbon dioxide is being removed from the atmosphere. So that's a good thing for the climate. What you can do is you can compare greenhouse gases on a more or less a like for like basis on how much they warm the climate over 100 years. So you can compare CO2, that's the amount that you're locking out in the atmosphere. You can equate that to the climate warming effect that an equivalent amount of nitrous oxide or methane would have. Now that's contested because some people say we shouldn't be measuring it over 100 years because methane is short-lived. We shouldn't be comparing it over 100 years. We should just be comparing it on the basis of a different metric. But that aside, there are ways, whichever metric you choose, of comparing the greenhouse gases on a similar sort of metric. So that's the scientific basis for doing it. I would just say that it's not really strictly a one-for-one comparison. So the people who say that methane isn't a problem, it is a problem, by the way, it causes climate warming. But the people who say it isn't a problem because it's just cycling very quickly, they say we shouldn't compare it to CO2 and methane on a 100 years basis. And I would say I would agree with them, but for a different reason, because methane emissions, because it's only short-lived in the atmosphere, it's only got a atmospheric lifetime of about 12 years. Cutting emissions now can make a really big difference if we're going to try and get to net zero by 2050. So in a way, stopping methane emissions is like the emergency brake that we can apply to stop the worst excesses of climate change. So it's not really comparable. So building soil carbon slowly doesn't compensate for not pulling on that emergency brake. We got to pull on that emergency brake at the same time as building soil carbon.
I'll maybe just follow up on that because I totally agree with Pete. It's not an either or here. We have to apply every mechanism that we've got. But I also think we've got to be realistic in grassland systems about how much carbon we can actually store in soils and restore in soils. And if we don't tackle the livestock methane, at some point there will be no soil carbon to increase or maintain, and you're still stuck with the same amount of methane emissions. So it's not an either or here. And as I say, equally, a lot of grasslands are already fairly high organic soils. So really what you're after doing, and often in these systems, is actually maintaining what you've got, increasing if you can, but definitely there's a lot of focus on maintaining what you've got. So yeah, not an either or, but throw everything at it.
Thanks. That's ever so helpful. Both those explanations are really clarifying. They take me on to what's a very simple question probably for you, but question for dummies like me. Can you explain in simple terms the difference between carbon sequestration, storage, and carbon removal?
I'll have a go at this one first, because I totally agree with you, Ellie. There's massive confusion about how people use sequestration terminology. So my gut instinct is to go back to where it was originally defined or to a common definition. And I like to use the IPCC definition of soil carbon sequestration and removal. So I'm going to paraphrase this. Soil carbon sequestration, it's a more generic term, or what you might say, it's more representative of what is happening in the soil as a process, as a biogeochemical process. So it's the mechanisms by which carbon is stored in soils, and it doesn't matter if we're involved with that or not. It is just the process by which carbon is taken into soils, usually via plants, and stored in soil. So it's agnostic to human intervention. And I think that's the difference between that and soil carbon removals, and that's specifically about the human activities and interventions that aims to take CO2 out of the atmosphere and put it into soil. So that to me is the distinction between the two. The second one, removals, is an active intervention by us. And it's also a term that's used in reporting by companies if they want to demonstrate that they're lowering their emissions and they're removing carbon from the atmosphere. They report GHG reductions and they report carbon removals. And I'd really quite like to see in the scientific community more adoption of these terms as they are used in the commercial world to try and reduce this confusion between sequestration and removals.
Brilliant answer. Nothing to add, Helena.
Nothing to add. Yeah, super clear. Oh, it brings me on to the question of saturation, which you touched on a little bit, but I think it'd be great to clarify a bit more.
Shall I have the first go at this one, Helena?
Yeah, go for it, Pete.
Yeah, basically, there's only so much carbon you can get into soils because the soil carbon or the soil organic matter is sort of locked up in the soils in aggregates and absorbed onto mineral surfaces. When you've got a large amount of carbon in the soil, all those surfaces are saturated. They're all used, so you can't get any more carbon into the soil. I like to look at it as like having a bucket that's full of water. Tipping more water into it doesn't fill the bucket up more. You just lose it out the sides. If you've got a half full bucket, that's a depleted soil, which has got depleted in soil carbon. Then you can still add carbon to it, just like adding water to the bucket. But grassland soils, as Helena said earlier, tend to be high in carbon. So they tend to be close to that high equilibrium or saturation point. There's some debate over saturation. So let's just call it the high equilibrium point. And there comes a point where you can't add any more additional carbon to those soils. So that's why some people focus more on degraded lands and cropland soils, because they're depleted in soil carbon. They've lost between 40 and 60% of the original carbon, which makes them a better target for carbon sequestration than the grassland soils, which tend to be higher in soil carbon already and closer to that saturation point.
Great. Do you have anything to add to that, Helena?
I suppose the thing that I would add to that is that we all also should remember that this is always a dynamic. So storing carbon in soils is about what you put in versus what comes off. And this idea of an equilibrium, it's a balance. It's not we've filled it up and it's not going to change. It's always a balance between in and out. And I think if we're looking to increase carbon in soils or reduce emissions, we have to think about what's going in and what's coming off. And is there any way that can be managed to change one of those two dynamics to increase the carbon store? So that's set against the fact you've got a natural capacity, an inherent capacity for different soils in different parts of the world to store carbon and reach a saturation level. But equally, we have altered these soils to a point where most soils in the world under agriculture are lower in carbon, but unless we radically change the land use or the management and the ins and outs, we're not going to change that stock. And I think we have to really think hard about that. Yeah, there may be massive potential theoretically to increase carbon, but unless we alter, how we manage that system, what we put in and what we take off, it's still going to stay at that level. And I think there has to be a degree of realism about what a soil will actually take in. And that, to me, this is where sometimes people focus on the saturation as, well, it limits what we can put in because it'll saturate. And I do wonder if any soils in the world are actually saturated given how much they've been managed and the pressures that they're under. But it's more important to think about, what am I going to change to enable us to increase that carbon, and how long might it take till it gets to the point where I can't really increase it anymore because I'm not going to radically change management or that soil hasn't got a capacity to take any more. So it's a combination of thinking about what's the inherent capacity, but actually thinking about the challenge of what am I going to do to change the ins or the outs.
Um, that's really clear. Thanks so much. I mean, I was going to go back to your bucket, Pete, if you don't mind, for the visual people that might be
Yeah.
listening to this or watching this. You're talking about the water spilling down the sides of the bucket. Can you talk a little bit about that? And maybe just can we say a little bit around soil carbon emissions, which we haven't talked about and I think are not necessarily always very clearly understood.
Yeah, sure. So soils are, as Helaina said in her answer, it's a balance between the inputs and the outputs. So when you're putting organic matter into the soil that contains carbon, that's the carbon that's going into the soil. At the same time, you've got soil respiration, which is going on, the degradation of organic matter that's in the soil and the respiration of the microorganisms and the plant roots. So these are called, that's respiration, and that's CO2 that's coming off, carbon dioxide. So there's always a balance of carbon going in and carbon being lost as carbon dioxide. So the analogy is when you've got the bucket and it's already full of water and you're tipping in a jug and it's all just running down the sides, that's the equivalent of everything you put in is coming out as CO2 because there's no place for it to be held. So it's just being lost mostly as carbon dioxide coming out into the atmosphere. A little bit of it will be dissolved and coming out in the water, going down and being washed with the water, but that's a smaller component of the CO2 going in. So that's basically the equilibrium point or saturation is when the carbon going in is equal to the carbon going out as CO2. And that's the equivalent of water running down the side of the buckets, if you like.
So what I'm hearing is that once you reach that equilibrium point, it's all about maintenance. So there's no
Yeah,
loss, but there's
that's
also
right.
no
So you can't get any more in. You can't get any more in. But as Elena said, you can easily lose a lot if you don't manage it properly. So in many systems that are high carbon, maybe the target shouldn't be trying to increase it, which is like biophysically impossible, but it should be to maintain it because those carbon stocks are very high. And when it's not in the soil, if we degrade the soils, that's coming out as carbon dioxide. So we're increasing this like negative sequestration, if you like. We're increasing the CO2 that's going into the atmosphere and making climate change worse. So the target should be to maintain the high carbon stocks in those high carbon soils. And in the ones that are depleted in carbon, then the target by changing management, increasing the inputs, decreasing the outputs, could be to increase it.
brilliant. Helena, did you have anything else to add?
No, I think that covers just about everything, I think. Well, as always, I've all got something to say. I think the other thing we've got to remember is there are also biophysical processes going on with the outs. So I was just thinking of grasslands there, and something that we maybe don't always recognise is we lose quite a bit of carbon in erosion. So again, it's thinking about where the losses might be happening and what can be done in terms of management. So it may be difficult to put more carbon into soil. For instance, grassland soils that have got high carbon, relatively high carbon, but equally we can slow down the losses by reducing erosion. So again, it's always thinking about where are the losses happening. They may be biophysical, they may be biochemical, greenhouse gas emissions, and as well as offtake as well. Obviously, plants are taking up carbon, they're taking it up out the soil. If we alter what type of plant structures we've got, can we reduce losses, increase inputs into the soil? So there's lots of things to think about in terms of what is it we're trying to accomplish in maintaining and restoring carbon.
Thanks. That's very helpful. It takes me into the question of permanence, which is maybe the other side of the coin of what we've just been talking about. So can you talk a little bit about those issues of permanence within this whole context of kind of, well, I guess, there's a market, isn't there, etc. And a lot of conversation around building soil carbon as an end game. So how should would we be thinking about the question of permanence of soil carbon? in the context of climate strategies.
Do you want to go
Want me to
first,
give this
Helaina?
one a go?
Yeah, go on. Yeah, and I'll
Yeah, I'll
come in
give it a go
afterwards.
because, again, this is another one where there are different definitions of what permanence actually means. And I think it's quite a difficult one at the moment in terms of consistency. Uh, so again, falling back on where guidelines come out, the Integrity Council for the Voluntary Carbon Market has recommended that any project or anyone reporting carbon removal should be looking at a 40-year period for permanence of that soil carbon removal. Which is great. And I know some soil carbon projects around the world have got 100 years by which projects have to maintain it. I suppose I would rather like to take the view that we started to think about the fact that we need to keep this carbon in soils full stop, because if we get it in there and we release it again 40 years or 100 years down the line, we're back in the same problem that we're at now. So perhaps we need to start thinking about permanence, not just as carbon removals, but permanence in terms of the benefits it gives us, in terms of soil health, resilience in agricultural systems, rather than just saying, that store has got to be there. That sounds great and simple. I think the biggest challenge we've got with permanence in agricultural systems, particularly cropping systems, is having a degree of flexibility around that. Because we tend to think about the fact that we change a management system, we put a carbon into soil, and that's it. Once we put it in, it's going to stay at that level. But most cropping systems are rotational around the world. So there is a sort of rotational dynamic in carbon over time. And I think there's an area where we need to think a little bit harder about how we view permanence that enables farmers to maintain a rotational system, which we know is really healthy for soils. It gives probably the best opportunities for farmers to have a productive system. But we know that there's going to be ups and downs. And the one that I always think about in Scotland is potatoes, because we are a big potato growing area. And we know that ploughing and other management practices associated with potatoes is quite destructive in soil carbon. But in a good rotation, that carbon is returned and can be built up. So if you come in and you look at just after potatoes, you go, oh no, there's no permanence here. But if it's a 7-year rotation, at the end of that rotation, it's gone up relative to the previous rotation, you've achieved your goal. So as I say, I think we do need to think about how the length of time, and that length of time also reflects how people manage the system. And the one gap I think we do have in the scientific knowledge is understanding that rotational dynamic and carbon cycling. And I think that's definitely an area that needs further work. I don't know if you, Pete, if you've got a view,
Yeah, it's
similar
great.
view,
That's
or
a great answer. I mean, just going back to the question, why are we talking about permanence? The reason we're talking about permanence is so that you can't get a carbon credit 1 year, then go and plow up your field, lose all the carbon, and lose, which is reverses your soil carbon, and then you claim the credit 1 year, and then you walk away with the money, and then go back to business as usual. That's the reason we've got these conditionality around permanence or durability. So I think permanence is, people are moving away from the term permanence and moving more to the term durability, because that's sort of like more encompassing. The geological storage can be for thousands of years. The biological stores are maybe for years or decades that they could be guaranteed for. But I think it's reasonable that we have some rules around that, so that you don't get perverse incentives to lose all of that carbon 10 years after the project finishes. So you've got a project for 10 years where you claim your carbon credits, and at the end of it you plow it all up, and then you go into a new one where you're gaining the carbon credits for building it up again, so you don't get those perverse incentives. So I quite agree. The reason it's there is to stop cheating, to stop gaming the system, So we do need some consideration of that. But you're quite right. That's not the end game. I think about the resilience that improved soil organic carbon, soil organic matter gives to the soil. It's all about the soil health and its resilience and its durability. And I think those are the key things that we should be getting across. We should take our carbon blinkers off and look at the wider ecosystem services that we're providing. I think that's me saying that with my carbon blinkers on usually. So I should do as I say, not as I do.
Yeah, or maybe just add a little bit to that, because again, as I said at the beginning, it's very confusing how permanence is used. And interestingly, with the European carbon farming regulations, they actually class soils as a non-permanent carbon removal. And
Yeah,
so they have a distinction between permanent, which is things like biochar, rock weathering, etc. Soils, forests, etc., are considered non-permanent. And then you think about how you manage it. And I think I like Pete's term durability. And you think about what's that durability and how do you maintain it.
Thanks. So helpful. There is this balance, isn't there, between, general soil health for all of those reasons, and then this whole question of climate strategies and also how to get people on board because obviously this is expensive for people to implement, etc. So we talked a little bit about farming systems, and of course there is a lot of acute attention on ruminant systems. I mean, that's where a lot of the studies tend to be. But there is this backdrop, as you mentioned, Helaina, of regenerative arable agriculture. So I don't know if you've got anything else to add on what the respective roles of arable versus grassland systems in reducing emissions and soil carbon removals, or whether you feel you covered that really in the previous answers.
I would probably say, again, it's not an either or in this. I think perhaps in terms of the scientific studies and in the press, we're hearing more about what's happening in grassland systems, particularly dairy systems. But my experience is actually the greatest rollout of what I might call low carbon farming practices is actually in the arable sector, where many commercial companies are looking to report reductions in their greenhouse gas emissions and hopefully eventually removals through their what they call scope 3 emissions. So food and drinks companies want to demonstrate that they are actually generating their products from agricultural supplies that are reducing their emissions. So that's really where there's massive movement. So although, as I say, the press might be more focused on livestock sector, the biggest movement is clearly in the arable sector. And I'm quite impressed, surprised at the scale of the rollout of regen agriculture in arable.
yeah. There are some overblown claims about which arise from this confusion about having a large carbon stock, the amount of carbon that's already in the soil in grassland systems, and assuming because you've got a large carbon stock, that is equivalent to sequestration. That's the net annual removal of CO2 from the atmosphere. So there's been a bit of miscommunication, maybe deliberate, maybe not deliberate, about saying that, dairy systems or livestock production systems are sequestering carbon. They have a huge amount of carbon, which is going to offset the methane. So I think there's a bit of tomfoolery going on, deliberately misleading in some cases, to try and equate the two together. To just sort of say, you can have carbon neutral beef, you can have in this grass-fed system, which looks nice because all the cattle are grazing outside, then it's going to be beneficial for the climate. And I think that's a bit disingenuous.
I think this comes back to actually where we started this conversation, and I think it's the devil's in the detail of how people are reporting these claims. And to go back to what Pete was saying, ultimately, just because you got a big pool of carbon does not mean you're sequestering. Well, more than what you were before. That's probably a better way to put it.
I'm going to have to ask, Pete, can you have carbon neutral beef?
You can't have carbon neutral beef, no, because the methane emissions come from the cattle. What you could have a carbon neutral farm that produces beef. There's an organic farm up near where I live in Aberdeenshire, which is selling itself as carbon negative livestock products, but not through soil carbon sequestration. As a soil scientist, I don't think that's going to be through soil carbon sequestration. What he's done is the farmer there has put aside the upland areas on all the slopes and planted up trees, and he's growing trees on that land, and the carbon that is sequestered in those trees over the lifetime that it takes them to grow, he's done the calculations, and it would offset the methane emissions if you count them on an equivalent basis. So if you're willing to put aside 25-30% of your farm into woodland, then you could have a farm that is producing beef that is carbon neutral or carbon negative. But just by saying we got large carbon stocks, so it's going to be offsetting the methane emissions, that doesn't wash with me. And I think there are deliberate attempts out there to confuse the public about that, to say there are lots of reasons why you might want to have grass-fed beef, because you might like the flavor, you might think it's good for welfare, you might think it's a nice environment for biodiversity and all that sort of stuff. You might like looking at the landscapes. There are many reasons that you might want to do that, but climate change isn't one of them. So let's not make that claim. Let's keep that separate.
Thanks. Well, that brings me to a very practical question, which I think ties in quite nicely. What do you think are the tools that are available to help farmers move towards net zero on their farms, presumably then reflected in their products? And are these separate from the tools needed to quantify and verify carbon removals? I mean, I think you've answered that in a way, but let's talk a little bit about what those might be.
Helaina, go ahead. That's your job now.
Yeah, I'll just start with yes, these tools are separate, but there is an overlap. So I will explain why I think they're separate, and then I'll explain a little bit why there is an overlap. As I said before, most companies are now looking, so food and drinks companies are looking to report their carbon removals to demonstrate that they're lowering their footprints or their contribution to climate change through something called Scope 3. Scope 3 reporting has quite specific guidelines. There isn't one for carbon removals as yet, I should say that. However, people are already gearing up to being able to report this when hopefully the guidance comes out next year. And they're using generally voluntary carbon market methodologies to do that. And they're quite specific about what you need to do. And particularly if you're using modelling, which most of this reporting does do, there has to be a particular type of modelling called Tier 3 that's effectively more complex, needs more data, and quite a sophisticated tool in terms of actually working out your emissions reductions and removals. But equally, if you're measuring your soil carbon change, there are quite stringent requirements for where you sample, how you analyse those samples, and then how you report the uncertainties associated with them. And the key word there is uncertainties. Whether you're using a modelling approach or a measurement approach, you have to report the uncertainties associated with your claims. And they are specified, right? If you're just looking at net zero and you want some guidance, there are simplified forms of many of these models, and they're called Tier 1 or Tier 2 because they're simplified versions of these models that can be used to help farmers guide where their emissions are coming from or where there may be opportunities to increase removals. Yeah, and there's many of them out there. They all give slightly different results. That's because they come from slightly different processes and places, I don't actually see a massive issue with that, particularly because they're trying to work towards making them give similar results. I think the key thing is for a farmer is they're using them as tools to say, where are the opportunities lying? Also, the difference with those tools is they tend to take in whole farm practice. So they don't just look at soils, right? So as Pete said, if you're really wanting to have a farm supplying a product that is genuinely net zero, then you need to look at your whole farming system. You're not just going to be looking at your soils. So those tools are very useful for that purpose. And then you say, well, have I got any opportunity in my soils for removals, or is it emissions elsewhere that I'm really looking for? Is it a land use change, etc.? Whereas, come back to where I started, is the tools for verifying carbon removals don't do that. They just focus on the soil greenhouse, the soil emissions and the soil removals.
Yeah, I think that the point that you've raised there about using these tools for understanding the system, for farmers understanding the system, there's a great example. I work with the Cool Farm tool a bit. We published a study a while back that was using the Cool Farm tool. Farmers that were producing organic eggs for Costco in the US used the Cool Farm tool. They were trained in how to use it, and then put together in a room where they just talk through why are your emissions lower than my emissions, where do you source your feed, where do you get, how do you manage the what you're using to heat the hen houses, all these sorts of things. No interventions, no targets set, nobody saying this is how you reduce your emissions or we expect you to reduce them. Just by those farmers talking together, within 3 years, they reduced their emissions by nearly a quarter, just through that peer learning that they got through understanding the system better and acting as a focus to talk to each other, to say, right, actually, you do it like that, I could do it like that, and lowering the emissions, which of course is lowering the costs at the same time. So it's a win-win situation. And it was fascinating for me to see through this process how the peer-to-peer learning worked to reduce the emissions without anybody setting any targets or any expectations. It's really, really amazing.
Can I just build on that a little bit? Because I think there's also something that I think has a degree of confusion for people, particularly farming sector, when they're looking to the opportunities, either through engaging with food and drinks companies for scope 3, or they're looking at voluntary carbon market. And I think there's a little bit of I don't know if it's a misleading assumption that it's easy to report scope 3 emissions and it's easy to report for voluntary carbon markets. And as I said earlier, you need something like tier 3 models that need expert input and a lot of data, and they're not for the faint-hearted. And I do really think we need, and it speaks areas of expertise are definitely not for the faint-hearted. But I think we need to help people understand there's a differentiation between what you can do yourself as a community, as an individual, and where you really need help to actually generate data that can be used for reporting. And I think it would be quite nice to start to be clear about those differentiations, because I think that has muddied the waters, particularly in the UK, about where opportunities lie to get paid for carbon farming, and an assumption that you can easily pick up a tool to report, and it's not straightforward.
Yeah, totally agree, Helena.
Yeah, I mean, it's this slightly strange triangle at the moment, isn't it, between a market, what might be regulation or kind of policy imposed, and then this confusing terminology we have around kind of behavioral change, which is sort of assuming you're not quite doing something you ought to, but not very clear what that ought to might be as well. That's really helpful. I mean, it brings me on to a question around kind of methodologies, which is, if you go to the standards end of things, who is it who writes the standards and sets those standards and writes the guidance for projects looking to actually sequester carbon in the soil? And if you go back to your point, Pete, around simply sharing best practice around sort of just like, the good things to do that can set you on a journey. Alongside that, presumably, if you're looking to actually get the money into a system that's going to push you in the right direction, there has to be something that's sort of to follow. So who is it who sets that?
Shall I start, Helaina?
Yeah, go for it.
At the high level, at the country level, this guidance was written by the IPCC, the Intergovernmental Panel on Climate Change, through their National Greenhouse Gas Inventories Programme. And I was actually involved in developing some of those methodologies, which Helena's referred to, the tier 1, the tier 2, and the tier 3 methodologies. I was involved in the development of those. And those are to allow countries that don't have capacity, that don't have a lot of data, to report their emissions. So this is meant to be the sort of the lowest common denominator, the tier 1, if you like, that allows every country, even with underdeveloped scientific capability and lack of skills and lack of data, to report their emissions and changes in their emissions. So that's at the highest level, at the national inventory level. But then there are a whole bunch of different protocols or methodologies that have been developed either at country level, like there's carbon farming in Australia. They developed some really robust guidelines, which are a combination of modelling and measurement to be used in their emissions trading system and their carbon farming in Australia. The EU is currently developing those methodologies for its carbon farming initiatives, which will also be a sort of, they call it the compliance market. That's the government regulated markets. But then there's also the voluntary carbon markets, where players such as Vera, they're a company that certify carbon removals. They develop their own methodology, but they don't just develop it in isolation. They consult with experts, and they have consultants and experts involved in that development. So they try to get to something that is robust. Now, there are debates about, are they robust enough? And I think, generally speaking, it's very difficult to get it scientifically to the best possible standard. So it's always a trade-off between what's possible. You don't want the system to be, costs you so much to put the measurements in place that it outstrips the benefit of any carbon credit that you get. So it has to be a balance between this sort of pragmatic simplicity and robust and effective monitoring. So, Helaina, over to you. You've got far more experience of this than I do now.
Yeah, and interesting. I think you're absolutely spot on with this idea. We have to have a degree of pragmatism in this. I think actually I'm going to split this into two things. I'm going to split it into the reporting requirements for the claims that are being made versus management guidance. And I'll come back to the management guidance. So there's something that's bandied around. It's called MRV. I like to say it's measurement, monitoring, reporting, and verification. And all of the guidance that's out there and all the protocols that are out there are really what they're trying to do is establish a robust and reliable MRV system. And if you drill into the details of all of them, most of them end up back at the IPCC guidance that relates to what Pete was talking about, where countries are reporting their emissions reductions against land use change. But they've morphed under different organisations and have slight differences and subtleties, etc. What I'm often asked to do is actually look at these methods, because companies say, well, I want to use this method. And often what I'll do is I'll sit and look at it and I'll say, who's produced it? Who is involved in producing it? Where's the independence? So Vera is a very good example. If you look at several of their methodologies, you'll often see that they've been produced on behalf of Vera by an organisation who's probably funded it. But then what they do is they bring in experts, and you'll see the experts or the organisations they work for. So you really want to see whether a methodology for reporting is substantive and actually will stand the truth of time is to look at who's been involved in writing it. And many smaller ones that may be circulating may not have that opportunity to really engage with the scientific community. Now, I think it's important to remember none of these methodologies are fixed in stone. Nothing is perfect. What you want to look at is how do they report the uncertainties associated with their methodology? Are they clear about how you report those and the procedures to do them? So that's what I tend to look at if I'm asked, we want to follow this method. So there you've got, this is the guidance of how you go about it. But you've always got to remember behind that are the organisations, the companies, the people that are actually on the ground doing the work. And they will have their own methodologies and protocols to follow that guidance or that standard. So if you're involved with a carbon farming project, you don't only just want to see the guidance, I'm going to follow Vera or I'm going to follow the FAO method. You also want to say, I want to see your methods of how you do this on the ground, and I want you to show me that they actually match what this standard protocol requires. And that it's so there's more detail behind it. It's not just say, here we go, here is the protocol, the standard, take it out in the field. That often is good guidance, but it's not again, the devil's in the detail of how you actually go about it on the ground. What diameter corer do you use? How many cores are you actually taking? How have you calculated that? How do you transport your samples back to the lab? What lab methods do you actually use? How do you quality assure those? That information will all be held by the companies or the organisations actually doing it. So I always say to people, make sure that you have that information stacked up. And the reason why it's really important is if you're reporting claims, particularly for the voluntary carbon market, you'll be audited on that. And you have to be able to produce the level of documentation that demonstrates how you've collected and reported the claim, not just the protocol, I followed this method. It's show me how have you calculated this? Where's your demonstration that your methods are robust? What do you do in the field for your quality control? So I think you always have to think about what auditing and verification is required, and do you have all the documentation to back it up? Sorry, it's a bit of a ramble, but I think it's quite important to realise that even if you have something like Vera or FAO or the IPCC, that's not enough. And to me, that's where the standardisation and harmonisation needs to happen more, is actually with what people do on the ground and less about these high-level methodologies. So I have a bit of a bee in my bonnet about that, and particularly around analysis.
Yeah, you said it's not for the faint-hearted. So you just answered the question I was going to ask you. Where do people therefore go to something where they've got some confidence that what they're doing is going to be following some kind of guidelines, or is what you're saying that we need those guidelines still?
Can I be just a bit cheeky on this one? I actually think that's where perhaps the academic community need to step up and engage more, because often what people want is a friendly face that they have confidence in, that will tell them the hard truth and help them navigate their way through this landscape. And perhaps, this could be a key role for LUNZ, in fact, in being able to offer that, that ear to help people guide this through, because it's not a recipe book. Every carbon project is different. Every scenario is different. So it's really understanding how people want to operate, implement, the farmers groups that they're working with, etc., to be able to really help people decide what's the best way to go about this, with a pragmatic slant to it. What's achievable, what's affordable, what's reliable enough to be confident in the outcomes. Can I just top and tail that? And I said there was something else I wanted to mention. I think this is something that equally in this I feel is building but still needs more work. And it's the guidance around the management opportunities for farmers. So everything's about how do we monitor this and report it. And I think there's less emphasis on how do we support farmers in making decisions about what are the most appropriate management practices for them if they're going to engage in this reporting. And I see that evidence is building. FEO produced a fantastic report on sustainable soil management practices and what might help achieve soil carbon sequestration. But again, it's then regionalising that, and how does that relate to farming in the UK? How does it relate to farming in Africa? And I think there's more work that sits alongside that in terms of guidance. And the reason why it's important is I often get soil carbon projects coming to me and saying, right, we want to report claims of carbon removals. What do you think is achievable over, say, a 30-year project? And I'll say to them, well, what management changes are you going to make? Because unless you know that, it's extremely difficult to say what is the potential in this environment, because it all hinges on what management changes and what are they likely to do on the ground in that location.
And when you say
So again,
location,
that also comes back to the fact that there's no recipe book for this. So I think to fill a short-term gap, this is where people who are willing and able to contribute to that conversation can help, because it'll take time for the guidance to be, to be regionalised. But things are happening on the ground now. And really the only way to have that knowledge exchange is through discussion and conversation.
and is location the first, is it clear in terms of location? I mean, is location the first thing to look at, and then you look at the management, because that will dictate what the management.
Yeah, location, what farming system is it? What management has, what's its current management? What's its future management?
And location, you're looking at the landscape, you're looking at the soil type, you're looking at soil depth, you're looking at the weather. That's what we're looking at.
Yep. Yep.
Pete, did you have anything else on that?
No, that was a great answer. Yeah,
Okay.
I'd definitely employ Helaina.
Yeah.
If I had a carbon project, should be the first one I go to. I mean, that's a brilliant point about these guidelines. Will say something like, make sure you take enough samples, but it doesn't tell you how to take the samples. So it doesn't operationalize it. I think that's what Helaina was saying. The operationalization of these good practice guidance. That's the thing that really differs. So I think having documentation for all that is necessary, and maybe that's where the scientific community could be doing a little bit, could be doing more, saying, look, if you've got a field that's got, this soil type, this is how many samples you need across this landscape. These are the best ways to do it. This is the depth that you need to go to, because those are the critical on the ground things that will make the difference. And you don't get any of that in the good practice guidance generally.
Can I make a plug?
Go on. Yeah.
So
that this podcast is not sponsored by Helaina.
no, it's not supposed to, but I think I go back to what I said before. Methodologies are always evolving. And I think it's important for us to remember that we're at quite a unique time in soil science and soil carbon, that we're generating data at scale now. And I mean, this is a generic we are. Soil carbon projects around the world are generating data that we've never seen the likes of before. And they're also operating at scales that we've never really had data for before. So historically, we've had a lot of field farm level experimentation survey studies. We've had regional and national surveys that work at very large scales. We've not had a lot of data that has filled the gap from farm to region, where it may be multiple farms, it may be multiple catchments. And we're now generating data at those scales that allow us to look at the questions about what is the sampling intensity, where it's required, what sort of depths are required, etc. Now, that that knowledge and data are starting to feed back into the methodologies. And this is where the plug comes in. And it's a plug for people to engage in a consultation when it comes out. So Vera, which is one of the most widely known standards, and it's widely known VM 0042, Improved Agricultural Management for Soil Carbon. They've been working with the academic scientific community to produce a soil sampling handbook, which tries to tackle some of the detail that we've just discussed. So it tries to bridge this gap between a sort of more generic methodology standard and what happens on the ground. Again, it's never going to be absolute, but it is trying to bridge that gap. And my plug or my request is for the community to really engage in the feedback for that, because that's how we improve this is through iteration with the academic. As we put things on the ground and operationalize it and generate data, we have this feedback loop. And I think it's important to recognize that. We're at the aim of trying to improve the reporting and reduce uncertainty. So how do we go about it?
Brilliant.
And maybe not get hung up on the fact it has to be one methodology right now that's absolutely perfect, because we're not going to accomplish it.
Great. Well, I mean, that brings me on to the questions around measurement and modelling. It would be really helpful to understand, and this might be one for you, Pete, what are the key things to understand about models and how they are applied, or even, dare I say it, sometimes misapplied. We talk
Yeah.
about modelling, and I think a lot of us don't actually really know what's involved.
Yeah. So the first thing to say about models is you can get them to say more or less anything depending on what you feed into them. So anything that relies on just modeling, I would be really, really skeptical of. Don't touch it if it's only modeled. Where models can be useful is they can be used for projecting the sort of carbon sequestration potential you might get in a project over 30 years. So Helaina said in an earlier response to a question, where somebody asked me how much carbon sequestration potential there is for a project, the first thing she asks, what management practices are you doing at the minute? How are they going to change? What you're going to be doing? What soil type you've got? And those things, they're the things that determine it. So what you can use the models for is you can use, if you know the practices, you know the local weather conditions, you know the soil type, you can run that model forward into the future and say, in 30 years, if you do this, as you say you're going to, you should have increased the carbon stock by this much. And annualized over that period, that would have been X tons of carbon per hectare that you removed in that project. That's where a model is really useful for doing that sort of projection. It's not going to be entirely, you couldn't nail your colours to the mast of the exact number, but it's going to tell you relative to other management practices you might try. It allows you to select the best one for your particular type, your particular farm type, and your particular soil type under that particular climate. So that's where it's really useful. You can also use models to ingest some remote sensing data to monitor what's going on along the time. But the bottom line between this, in all of it, is to take the measurements. I trust the measurements over the model. I've worked with models. I am a modeler, and I've worked with models for 30 odd years, and always compare them back to the measurements. I don't trust the model until I've got verification with actual measurements that this is the case. Measurements have uncertainties as well because of the spatial heterogeneity in the field. So you're going to have an error bar around your measurements, but does the model go through the error bar? Like, is it equally good or bad as the measurements? So that's what you have to demonstrate. So I think a combination of modeling and measurement, most of the good protocols I've seen have a combination of both, but there is the primacy, I think, of the measurements, of the observations. That has to be the primary focus. And anything that you projected forward, if you're going to be claiming carbon credits, because we've only been running it for 2 years, it's not enough to demonstrate a change yet. But this is what the model says. If you're going to be claiming carbon credits during those first 5 or 10 years where you can't measure a change yet, then you've got to be confident that you're going to be able to measure it at the end.
So they're essentially a kind of strategizing tool to kind of focus your aspirations and start getting on with the job, but you actually have to measure whether and feed in those measurements at the same time.
Yeah.
Can I follow on from that? Because I think at the moment, this is where there's some room for discussion and debate. So at the moment, most carbon projects have to measure at the baseline. Usually he uses input data for the models in some shape or form, if they're using this model and measure approach, or measure and model. Then it stipulates in most methodologies, standards, you have to go back within 5 years to resample. Now, we know that the ability to detect change in 5 years under most agricultural management practices is going to be slim, and it's a numbers game. But actually, where I have questions is about what happens at this remeasurement, what the model is called true up period, when they use the data from the resampling to recalibrate, revalidate, or verify what the model outputs are. Now, at the moment, I mean, I'd love that if the models in the method had to do what Pete has just explained, which is there is some correspondence between model predictions and measured on the ground. We know they're not going to be exactly the same, but there's a lack of clarity in all standards and all methods about what this correspondence should be. And in fact, some discussion about whether there should be any correspondence. I mean, I have had people say to me, well, measurement's so uncertain, why do we have to bother with the models matching it? Which is a little bit intimidating for me and a bit scary. But I do think, again, this is, I think, a big thing for the academic community. What do we expect from correspondence over time between model predictions and measurement on the ground? And how do we operate that? There's a massive gap. Because at the moment, it doesn't have to happen. And there's been a lot of discussion recently about this, and I don't think it's resolved yet. So, Pete, something definitely to engage in that debate. There are commonly two approaches when it comes to certainly voluntary carbon market about reporting carbon removals. And one is called model and measure, we discussed, and the other one is measure remeasure. I'm not going to go into the details about that, but there is a broader discussion about whether we should bring those two together and actually have what we call a measure. So you're doing your baseline measurement, you're modeling your interim period, and your remeasurement is actually essential for your carbon removals to demonstrate you've actually achieved them. And I think that's actually doable. But I think what's interesting there is the scale at which you do that at. And the reason why I bring that up is, I think one of the reasons why models are being used so widely is because it's the only way you can really quantify your greenhouse gas emissions reductions. So if you're doing that already and you want to track how your carbon removals are happening over time, potentially, you're going to use a model. So we need to find a way to combine the strengths of measure, remeasure with the model, which gives us some idea of dynamic. And as I say, there's quite a lot of discussion about how we might be able to do that. And I'd quite like to see a move towards that. So that comes back to what Pete said, where you actually use the remeasurement as the truth of what is happening on the ground. And it gives confidence that that removals are actually happening. But we have to be realistic over the timescales at which we can actually achieve that. And perhaps the role of models there is helping to demonstrate that transition and that trajectory over time is doing what we expect it to do. And maybe it could be used to help farmers or projects tweak where we think things are not happening the way we'd hope they would do.
Yeah, that's really helpful. It's actually answered the next question I was going to ask. So, which was around this question between the comparability between model predictions and resampling data. So, yeah. I mean, just taking everything you've just said on this question, if when talking to policymakers or discussing these issues with them, what would you be recommending when discussing soil carbon models?
Oh, well, I'm not a modelling expert, so I always keep it very, very simple. If anyone's going to ask me, I'd have to keep it very simple. But I think the other thing is that there's often an assumption that modelling and sensing and others are cheaper than measuring on the ground. So it's an either or. And I go back to what Pete said, we can't operate in this space without having both. You can only run the models and improve the models if you have direct measurement. And equally, we can only fill the gaps in and help demonstrate trajectories and inform on management changes with the models. So it's not an either or. And I think we really do have to emphasize that with policy people, because there is a tendency to think, well, I can do it by a model, I'm saving money. And that's often not the case, because these models often need a lot of data and a lot of effort to generate those data. And I meant data, I mean not soil data. That's probably, I should have clarified that.
Okay, do you want to say any more about that?
Me or Pete? Maybe Pete.
No, I think was that just a question about what other data? It's things like the
Yeah.
meteorological data and the management data and all of those things, the soil bulk density, you know, the things that aren't soil carbon. There's a whole bunch of auxiliary measurements that you need to drive the models. Most of them being management and meteorological.
Right. And Pete, did you have anything else to add about, how you would help guide policymakers in this space?
No, we're totally on the same page here. Just because models are easier to do, and they probably are cheaper. It's cheaper in terms of, you've got one modeler sitting in a dark room in a basement somewhere, as us modelers do, versus sending people out into the field, and all the travel and subsistence and the analysis is going to be cheaper. But I mean, the point I'd like to get across, and I think our policymakers in the UK understand this totally already, so it's not a problem, is that modelling is not a replacement for measurement. It's something that can complement it, but the measurements are primary.
Great. Helaina, you were just about to say something.
Yeah, I just wanted to follow up with Pete's comment about the model being cheaper, because I wanted to contest that a little bit. But I want to contest it in the context of commercial carbon projects on the ground and my reflection on how I see they operate. Because I said most of them are modelling and they're reporting emissions reductions and removals. And it is the amount of data they have to collect from the farmers in their projects is enormous and actually quite onerous in many instances. And I certainly have had feedback that it's the burden on farmers in particular to actually provide that information is quite onerous and underestimated and undervalued, to be perfectly honest. And there is a huge cost there. And if we were to reflect on what we were talking to with policymakers, in UK, many farmers have to enter management data for subsidies and other schemes. And I would think if I was talking to policymakers and trying to support the modelling community and carbon projects in general and carbon reporting in general, I would say better access to that relatively consistent, already entered data would reduce the cost and the effort, particularly on the farmers, to engage in these schemes.
That's helpful. It brings me on to a question about the modelling community. Is there anything that either of you feel that we need, anything more we need from the modelling community going forward at this point?
I think the modelling community can always be reminded that to keep it simple. So there's a tendency amongst modelers to try and get everything perfect, to include as many processes as you possibly can, to get a more accurate reflection of reality. But I think what we need for practical purposes for carbon sequestration projects or carbon removal projects is something that's parsimonious, something that's simple enough to use, simple enough to understand, and that also makes it transparent. So the modelling, in the same way as you have to document all your measurements and what protocols, samples you've taken, how deep they are, you really need to do that with the modelling. And with a simpler model, it's easier to document, exactly what you've done. Because as I've said, you can make most models say anything you like by feeding it inappropriate data. So having simple data that you can make publicly available, then it can be transparent and verified.
I'm going to say something that I've been saying for decades. And what I'd really love is to see us move to more towards a model that the climate modelling community use, where they use ensemble model approaches. There are only a limited number of models that are used for reporting carbon reductions and removals. And it would be really nice to actually see more of an ensemble approach where we see these models being engaged in projects running 3 or 4 models, so that it's not one model against another. We actually have a true reflection on what we think is happening on the ground. I'd like to come back to the transparency thing. It actually surprised me recently. Been doing an exercise to try and improve on sampling numbers and sampling design to support modelling of carbon removals and reductions. But it all hinges on a really good understanding or knowing what a model prediction error is and how the model works a little bit to get a sampling error. I'll leave that one. But the model prediction error is actually critical to understanding how do you improve the input data to a model. And I will go back slightly counter what I said before. Going out in the field to collect data is a relatively expensive thing. So you want to make the most of it. So you want to make sure you're collecting the right data, the right amount of data in the right place. If you're doing a measure and model approach, you need to understand how that data are being used by the model to refine and make your sampling more cost effective and more effective for the modeling. But most models don't have enough information about how they generate their model prediction error at the end for you to be able to do that iterative process. It has surprised me quite recently, and trying to get numbers out of people about that have been quite challenging. So I think more transparency about that, or even having examples whereby people could test their sampling design and the sample numbers against a simplified model, or a model whereby the model prediction error is known, so that you can demonstrate how your sampling design and collection was improving a model. Very long-winded answer, but I think this is transparency about what a model does and what it generates at the end is critical. And uh, and I think the other thing is, I said already, there's multiple models out there, and people generally don't know which one to use, and is one better than the other? And we could do with having a set of consistent performance criteria by which people who are not modelling experts could actually get a better handle on what might work better in certain circumstances versus another, if we can't go to ensemble models.
Can you explain, we've mentioned it already briefly, but what is meant by inventories and what's meant by scope 3?
I'll kick off that in relation to soil carbon projects. Maybe Pete might fill in terms of the broader context of inventories. So when you're reporting your soil carbon removals, you have an opportunity to report them under 2 routes. One is an intervention route and one is an inventory route. So under scope 3 guidance, if you want to report by inventory, you report your changes against the measured baseline at the start of your intervention, your management change, right? And you don't need to worry about tracking and measuring the difference between what they call business as usual would be, and how your soil carbon changes under your new management regime. So it's effectively, I measure change against the baseline at the start of a project. It doesn't account for the fact that your carbon might have changed anyway under your business as usual. That's inventory reporting in the scope 3 sense. And it makes things fairly simplified. If you're reporting under an intervention reporting, then you have to have an estimate of what would happen under your business as usual. And you can do that through modelling, or you can do that through having control sites. Because what you're saying is what I'm reporting is the difference between what would have happened anyway under my business as usual versus what's happening because I've added the intervention. And those that want to get value, however you quantify that value, whether it's monetary or otherwise, for the intervention change, for actually funding the management change, often want to report by intervention reporting because they can say, this is what I've contributed to the change in carbon. But there are broader meanings of inventory and carbon removals beyond scope 3.
So my final question is really an opportunity for you to think in a blue skies way about how to take this whole space forward, which is what do we need next from the IPCC?
Shall I give this one a go? So I see that as really the way to harmonize, standardize across the world. The IPCC is seen as the source of guidance for reporting carbon changes under land use change. Yeah. And that guidance has been used for many decades now. We're only then one step on to now start to look at we need guidance for management changes. And I know it's a massive exercise, but the IPCC was central in bringing together the expert community to establish that common methodology and common approach. And I would like to see that repeated for land management changes on the ground. So that would help to harmonise and standardise what's out there currently.
Thanks, Pete.
So there are land management changes reflected in the 2006 IPCC revised guidelines, where you can look at cropland remaining cropland, grassland remaining cropland, and there are equations to help you calculate your stock change given a change in practice. But those are relatively simplified. They're not down to the individual intervention they might do, like reduced tillage, zero tillage, cover crops. They're not broken down by that. They're sort of like, are you increasing your carbon inputs or decreasing them? So there could be a development that refined that further down to individual, firstly by soil type, by climate regions, and then by different cropping systems and different management interventions. That's a huge amount of work, and you risk the issue because you've got data at the global level that this is all based on. When you subdivide that into the regions and then by different management practices, by different crops, different soil types, you get smaller and smaller number of data points against which to check that. So it'd have to be done by consensus by a large group of people. That would be really valuable. I don't think IPCC are going to be doing that anytime soon, because the original purpose for this guidance was to allow the countries that have the least capacity to put some numbers together against which you could compare through changes in the future. And I think what we're talking about is maybe moving away from that tier 1 basic methodology. And we're already starting to move up towards a tier 3 then, even though we're not explicitly using a simulation model to do it. So maybe this is what IPCC had in mind when they were saying tier 3 methods. This would be one of the tier 3 methods that countries could adopt. So maybe this isn't for the IPCC to do. This is for individual countries and organizations and multinational organizations to step up and do that job because they have the need.
So final question. We've talked about things going on at different scales, and we're starting on the ground and kind of going out, and there's so much happening on farms, yet regions, countries, continents, the world is looking at this question. And of course, carbon is a global issue. So how do we overcome or really understand these questions of scale in this context?
I think we have to look to where we think reporting carbon removals may be going in the future. Just thinking about what's happening in Europe, when you look at their carbon removal, soil carbon farming schemes and broader, there's a clear view that at some point carbon removals from land management changes will contribute to national reporting or even EU level reporting. And you can see this around other countries around the world who've already implemented this. And at the moment, there's a gap in understanding of how that's going to operate between the growing number of commercial soil carbon farming projects on the ground, whether it's voluntary carbon market or whether it's Scope 3, who are operating at maybe multiple farms or across a region or a catchment, etc., and then generating the data that then can be reported at a national scale. And actually, I think we need to start to think about how we can join those up, because we don't want to lose the wealth of information and data that's being generated at a finer scale that could contribute to national reporting. And this comes back to what that mechanism might look like. And I think at the moment that's a little bit unclear. But it's certainly worth thinking about the fact that looks like that's going to be on the horizon.
Anything to add to that, Pete?
No, that was a great answer.
Well, it's been a really great, rich conversation. Thanks both to our brilliant experts. We will produce a kind of written summary of this for people who don't have sort of an hour and a half now to sit down and listen, and look out for other podcasts in this series. So thanks, Pete. Thanks, Helaina.
Thank you.
Thanks, Ellie. Thanks, Pete. Bye.